The single most important problem in modern physics is linking general theory of relativity (GR) and quantum mechanics (QM). But why haven't we been able to do this, and is it possible that we might have found a way of unifying these two? To answer these questions, we must first understand what a standard model is. The standard model of physics displays the 12 building blocks which make up everything in the universe. 6 quarks, which are the smallest particles that we know of as of today, and that make up things that you know such as neutrons and protons, and 6 leptons, the most famous of the 6 being the electron. Within the standard model we can find the particles that act as carriers for the 4 fundamental forces of our universe. The photon for the electromagnetic, the gluon for the strong nuclear, the W and Z bosons for the weak nuclear, and although not yet found, the graviton for gravity. The identity of 3 of these force carriers has been proven. However, it has been found to be a difficult challenge to prove the existence of the graviton and fit gravity and GR into this quantum mechanics framework. The problem with these two is that they describe the universe in 2 distinct ways. GR states that any physical quantity can be determined at any time, having a deterministic nature. Imagining this ball as a quark, GR allows us to be sure that it has an exact velocity of 10 meters per second and an exact mass of 5 kilograms, hypothetically. However, the key to quantum mechanics is its uncertainty principle, which states that there are features in the microworld which you simply cannot nail down with total precision, making the microworld probabilistic in nature. Therefore, with QM, we can no longer be certain of the physical quantities of the ball. We can only predict the probability of it being a certain value. Nonetheless, we believe that we might have found a solution to this problem. We call it string theory, and it states that every elementary particle is made up of tiny vibrating strings. The type of particle that it will form will depend on the way in which these strands or strings vibrate. Each type of vibration will correspond to a different elementary particle, just like the note that you play in your violin corresponds to a specific string vibration. Why is string theory the answer to all our questions? Well, imagine a piece of paper with writing on it. If it is squashed, you can hardly tell what it says in the piece of paper. However, as you start to unwrap it, it spreads and smooths out, and you will start to understand better and better what it says on the piece of paper. This is basically how string theory solves the issue. When you go from a point particle to a string, it makes you spread the particle out, which results in the spreading and smoothing of the fabric of space. This decreases the amount of quantum uncertainty just enough so that QM and GR can coexist by finding a midpoint between the probabilistic and the deterministic nature of both theories, therefore solving the biggest problem faced by modern physics.